ladies and gentlemen. How are we doing today?
No, you told me that you had 3 zeros for some.
No, because that one was digital.
Okay. We'll try to get that cleared up for you today, okay? All right. All right, ladies and gentlemen. Welcome to our last Monday together this year, ladies and gentlemen. So let's enjoy it. Let's get through some things, and let's get ready for your test, which is tomorrow, ladies and gentlemen. So with that in mind, let me get attendance and take a look at the board. Today is basically your chance to ask questions, to get clarification on things, to get an last-minute understanding of things that we are going to have on our test tomorrow.
We're not.
Just hold on. Just hold on.
Okay? All right. All right.
Me. Why are you asking me? Are you stupid? No, you're stupid.
Wow. Brindley, you should be a member of our welcoming committee for the class. Okay?
Jeez.
All right.
Is it right?
Yes.
He's a charting one. Or is it dead?
The moment of truth is dead. Computer isn't dead.
Oh, yeah, it's cheap.
For the entire weekend, it's so alive.
All right, ladies and gentlemen. So I got a few things to do to review with you for today before your test tomorrow. But I guess the question that I would like to know, and again, Brindley said she wanted me, well, I don't know if she said she wanted me, but she said she didn't quite understand some things. So I'm going to go over some of the things that we talked about last week, okay? And then I will go over what's going to be on the test, and then we will talk about it. So let me grab a couple of things first here, ladies and gentlemen, okay? All right. All right. So, one of the things that we talked about at the end of last week that is important for us going from here forward are taking measurements. Okay? Now, when you take a measurement, ladies and gentlemen, you need to look at an instrument, you need to determine its precision. Its precision is what place it is marked out in. Okay? Different instruments are marked out in different places. Now, digital instruments make it easy for you. Because any digital instrument, whether it is a balance, whether it is a thermometer, whether it is a micrometer, anything that is digital, all you do is write down what you see on the display. That's it. No more, no less. You write down what you see. So, for example, ladies and gentlemen, when you are using a stopwatch and you hit start, and then a little while later you hit stop, I would write down 2.84 seconds because that is what is displaying on the stopwatch. That means the precision of this instrument goes to the hundredths of a second. That is the precision that it goes to. It reads to 2 places beyond the decimal. Okay? Again, the balances. We had a balance last week that read to 1 place beyond the decimal, a balance that read to 2 places beyond the decimal, and a balance that read to 3 places beyond the decimal. So all we do when we take a measurement, ladies and gentlemen, is record exactly what is shown on the display. Questions on that? Okay. Then we have instruments like graduated cylinders, and we have instruments like rulers. Now, these were meter sticks, and I modified them. I put tape over this so that the only thing there are no marks on here, none whatsoever. Which means this is a meter stick that reads in the ones place. It is 1 meter long. That is all we can tell by it. Now, because we are reading an instrument or using an instrument that is precise to the ones place. So this is 1 meter. That's all it can tell you. Because we are using an instrument that reads to the ones place, we are allowed or we are required to make our measurement to 1 place beyond that precision. 1 place to the right of the ones place is the tenths. So if we were to use this to measure the height of the door, ladies and gentlemen, I got 1, I got 2, and then I have this much more. So I know the measurement of that door is greater than 2, and I know it is less than 3. So I get to pick how much of this ruler I think this distance is. But I can only go to the tenths place. So I could say 0.1, 0.2, 0.3, some number like that. Now again, this is very close to the end. So I'm thinking 0.1, 0.2, maybe at maximum 0.3, but it doesn't really look like it's a third of the meter stick to me. But again, you can pick that last digit. We know it's more than 2. We measured it. It's greater than 2. And less than 3. So now you need to pick a number somewhere in between those. That's what we mean by estimating 1 place beyond the precision of the instrument. We know the measurement is between 2 and 3 of these. How much between 2 and 3, you get to estimate that. Okay? Now, if we were to take something that is a little bit more precise, and again, all I did was took a meter stick here, put tape on it, and then marked it off in tenths to make it read to the tenths place for you. Okay? So now we come over to the door. Again, 1, 2, and now I know that it is more than 2.1 and less than 2.2. Since this is reading in the tenths place, I now have to pick a number in the hundredths place to represent where my finger is between what amounted to 2.1 and 2.2 meters. So again, you get to pick. It's pretty close to in the middle. Maybe you'll say 2.15. Maybe you'll say 2.14. You get to pick. You get to decide. But the important thing is because this instrument reads to the tenths, you have to make a measurement to the hundredth. Questions? Okay. So now, we used 2 different instruments on last week to take density. We used a balance and we used a graduated cylinder. Each of those instruments had their own precision. Each of those instruments had their own precision. So we had to combine measurements. Okay? So density is equal to mass divided by volume. Well, mass comes off of our balance. And our balance reads to the thousandths place. So when we take a measurement, we get something like 15.265 grams. Okay? But our volume, ladies and gentlemen, comes from a graduated cylinder. Graduated cylinders are not nearly as precise as balances are, at least not ours. Matter of fact, our graduated cylinders could only go to the tenths place. That's as far as they could go. That's the best graduated cylinder I have in this building. So now you get a number such as, let's say, 6.2 milliliters. Now, again, a lot of you didn't do 0.2. A lot of you did 0.0. Why? Because it's hard to estimate marks that are very close together. It is hard to estimate where the number is between them. That's fine. You could make it 6.0. But you have to get to 0.0 because that is the precision of the instrument. It reads to the ones place, so you have to go to the tenths. But now when you divide these numbers, ladies and gentlemen, this number on the top here, leaf, how many sig figs in 15.265? How many sig figs are in that number?
5.
There are 5. How many are in the number 6.2? How many are in the number 6.2, Meryl?
2.
There are 2. Now, the rule for division says that after you do the math, you can only put your answer into the smallest number of sig figs, which is 2. So, I get my number out of my calculator, 15.265 divided by 6.2. And this is the number I get out of the calculator, 2.46209. 6774. And the only reason this stopped is because I'm out of digits on my calculator. I would imagine it would keep going. Okay? This is the number we get out of the calculator, but this is not, all of these digits are not significant. All of these digits do not have meaning. All of these digits were not measured. By the rules for sig figs, the most that we can do is 2. Okay? So I look. This is the first sig fig. This is the second sig fig. So now what I'm actually doing with this number is rounding it to the tenths place because that is where the second sig fig is. The number after the 4 is a 6. That means I'm going to take that 4 and I'm going to move it up to a 5. So our answer for the density is 2.5 grams per milliliter. Because that is the best that I can do with this calculation with the instruments that I use to make it. Questions? Cynthia.
But how do we know when you're adding like the other zeros? Like, you know, sometimes you do 0.5 and then the rest of the numbers, instead of putting them down, you write them into zeros.
Okay. Here's why. Okay. So let's say you get a number like 4,325. Okay? That's the number that your calculator gives you. I can't even think of a calculation right now, but that's the number that your calculator gives you. Okay? So let's say this is grams. Now let's not do grams because let's say this is meters. Okay? We do some calculation. We're finding something and we get this meters cubed for the volume of something. Okay? But the rules for sig figs say this number can only contain 3 sig figs. That's all we're allowed to do. So the numbers that we multiplied together to get this total number, they were all limited to 3 sig figs. Okay, so our answer can only have 3. The third sig fig in this number is the 2. That is the third sig fig. So I need to take and round this number to the tens place now because that's where the third sig fig is. So to round this to the tens, this 2 is going to move up to a 3, right? So I cannot make the number 433 because that is a different value. Yes, it has 3 sig figs, but this number is a different value from this one because this was 4,000 something. This is now 400 and something. So what do we do for this place? We put in a 0. We put in a 0 to hold that place. To make that 4 stay in the thousands, this 3 in the hundreds, this 3 in the tens. Okay? Now this number only has 3 sig figs, but that's all we could have. Okay? Now I put in a 0 to hold the place, but it is not significant. Why? because there's no decimal. So without a decimal, this 0 is not significant. Meaning this measurement goes to 3 sig figs to the tens place. Does that help?
Yeah.
Okay. Now, let's say we do some math in your calculator. Let's say, again, we're finding a density because this one I know I can do much easier. And your mass is 12.000 grams. Exactly 12. Okay? The volume that you get works out to be 12.0 milliliters. Okay? When we divide these, what are you going to get? You're going to get 1. This is what your calculator will give you. It'll give you the literal number 1. Okay? Doesn't care about all these zeros. It will give you 1. Now, this number on the top had how many sig figs? 12.000. Rocio, how many sig figs there? All 5. The 3 zeros at the end are significant because there's a decimal in the number. The 12.0 on the bottom has how many sig figs? 3. So this answer has to have 3 sig figs. The problem is right now it only has 1 digit. So we are going to add a decimal and we are going to put 2 zeros on the end. Now, first thing, originally the number was 1, correct? What is it still? 1. I have not changed its value. Okay? All that I have done is made 3 sig figs by adding 2 zeros at the end. Okay? These zeros are significant because the decimal is there. Now, value-wise, I did not change the number, but I did change it in terms of sig figs, and that is what is important in science. This number, 1.00, is a lot more precise than the number 1. Shows that it has 3 sig figs, shows that it is precise to the hundredths place. And that is what we need to maintain when we do math with sig figs in science. We can't change values, but we need to maintain the sig figs as well. So either how many there are or what place you report to, we have to come up with answers that are the correct amount of sig figs and the correct value. Here I added a 0 to make the correct value, 4,300. The 0 is not significant, but it's necessary, otherwise the number becomes 433. Here I added zeros that did not change the value, still 1. But they are significant and they show more precision. Does that help? Okay. Other questions?
What if it's like a 0.00 and then a 5?
All the zeros, okay. What you really got to ask yourself. So give me that number again, please. 200.0. Okay. Now, is this the number out of your calculator or is this a number that we're trying to count the sig figs on? Okay. These zeros are all considered to be where in the number? In the middle. Okay. Do not let a decimal point affect where zeros are. Those zeros are in the middle of that number. Zeros in the middle of a number are always significant. Always. So 1, 2, 3, 4, 5, 6 sig figs. Always. Okay? Always. Now, here's the one. Oops. Stop it. Here's the one where people normally get confused. Okay? Now, without that decimal, where are those zeros? Beginning, middle, or end? All of them are at the end. All of them. And there's a decimal. That means they're all significant. Count them all. Okay? So zeros at the end are significant if a decimal point is shown. So this would be 5 sig figs. 5. Now, what if we had a number like this? Okay? Now, these zeros are where? Beginning. What do we know about zeros in the beginning? Don't count them. Okay? These zeros are where? At the end. What do we know about zeros at the end? If there's a decimal. Well, there's a decimal here. So count these last four. That's your 4 sig figs here. Zeros at the beginning, never count. Zeros in the middle, always count. Zeros at the end, sometimes count. If there is an actual decimal anywhere in your number compared to these zeros at the end, count them. If there's no decimal, don't. Okay? No decimal, don't. So this would be 4 sig figs. Okay? Questions? Yes. Go ahead. Other questions, ladies and gentlemen? Do you remember the terms that we gave you at the start of the unit? Experiment, constant, variable, independent, dependent, hypothesis. Yes? You are going to be asked to define 4 of 6 given terms here. On this test, I give you choices, ladies and gentlemen. There are 6 terms here. You only have to define 4 of them. You can pick the 4 you want to define. Okay? But again, hypothesis, an educated guess, an if-then statement. Constant, something that doesn't change in an experiment. A control, something you compare to, or a baseline. An independent variable, something that the experimenter changes. A dependent variable, something that changes because of the independent variable. An experiment, a carefully controlled series of observations. Yes?
If you answer them all but get like 2 wrong.
Great question. I grade the first 4. Okay? If you do them all, your choice, but I don't pick through and pick the right ones and not the others. Now, if you want to answer all 6 and then go back and cross off 2 because you're unsure of them, feel free to. But I actually don't want you to answer all 6. I don't want you to waste your time. But what I do want you to do is answer the 4 you're most confident in. So if there's a term there and you're like, I don't really remember what that means, skip it. Do the other ones. Now, if you find that you're 1 short, now you got to go back and answer 1 more. Okay? But on this test, there are a number of places where you will be given choices. If you do more, I will grade the first 4 of them, and then that's what you get your grade based on. Okay? Are we clear on that? All right. So then, ladies and gentlemen, you're going to be asked to define chemistry. It's a 6-point definition. I want the definition that I gave you at the start of the year. The science of the study of matter. Its structure, properties, compositions, and the changes it undergoes. Write it down on the top of a periodic table. Make sure you have it, because on this test, it is worth just under 10% of the test. The test is 74 points, and that definition is worth 6 of those 74 points. Okay? Now, we also talked about precision and accuracy, correct? Okay. So I'm going to give you a number here, ladies and gentlemen. I'm going to give you a number here. Okay. Give me a number that is more accurate than that number.
14.61.
No.
14.60.
You can't do this. Why?
Because you don't have a target. Oh yeah.
Thank you. You're confusing precision and accuracy. Common mistake people make. To be able to use accuracy, you have to have a target. All right. So our target is 14.7 psi. Now create a number, any number that is more accurate than 14.6 psi, which means our number has to get what? To 14.7. So give me a number that is closer than 14.6 to 14.7. 14.61. That number would be more accurate. Actually, you could go all the way up to 14.79 because it's still closer. This is off by 0.1. This is off by 0.09. Any number that is closer is more accurate. Any number that is further away is less accurate. Okay? Questions on that? Okay, now I want a number that is more precise. How would we create a number that is more precise? Create another place after the decimal, such as
14.62.
any number that goes further beyond the decimal than this one does will be more precise. Give me a number that is less precise. 14. And again, we're not worried about any target here. We're not worried about getting closer to some number. All we're worried about is writing a number that is less precise or more precise. Okay? Questions? You will be asked to do this on your test tomorrow. You will be asked to do that. Okay? Well, we just did it. How hard is it to do? But the one thing that people will do is they will confuse this and this. Accuracy has to have a target. And don't be surprised if I give you a target even if I'm asking for a more precise measurement. Because I want to see if you're going to use it. Now, to be honest, if your number becomes more precise and more accurate, I don't care. But it at least needs to meet the qualifications I give you. It either needs to be more precise or less precise, more accurate or less accurate. Questions? You are going to be given pictures of an instrument on the test. And you are going to be asked 4 things. Number 1, what is the instrument? It will be fairly obvious for you. Number 2, what place does the instrument read to? Is it reading in the 1s? Is it reading in the 10s? Is it reading in the 10s? What place is it reading to? What place would you report your answer to? Which is always one more to the right, as long as the instrument is not, and I'm not giving you a digital instrument. Okay? And then you will be asked to make the actual measurement. What would the actual measurement be? Okay? So again, if I gave you something like this, what's the instrument? Meter stick, ruler, any of those is perfectly acceptable. What place does it read to? The 10ths. What place would you report your answer to? Hundredths. And then maybe it'll show it, going up to a table like this. Okay, you got to give me a number. 0.72, 0.71. Put the unit on it, meters.
Is it going to be on paper or computer?
It's on paper.
So are the pictures going to be big enough for you to see the measurement?
Of course they will. Okay? Of course they will. And here's the other thing. I will give you some leeway. It's not like I'm going to be like, oh, you were off by 1/10. No. So, I mean, if I give you a picture and it comes out to here and you tell me that's 0.85, you're not getting credit because that's not between 0.8 and 0.9. Okay? But if you tell me that's 0.55, 0.54, 0.56, something like that, yes, you will get credit. Okay?
Wait, so that would be tenths, right?
This is reading in the tenths, which
Tens
means
or ten?
tenths. Tenth. Tenths. 0.1. Okay? Which means that then we go to the hundredths, 0.01. Okay? So again, if you give me something like 0.55, 0.56, 0.53 even, I will let it go. Question?
Will it ever go up to like 10,000?
No. That was a rarity in the lab where our instrument read to the thousands and you had to go to the 10,000s. That one was a rarity. Okay.
So it'd just be like hundreds.
Normally precision is going to be in like the tens, the ones, the tenths, somewhere in there normally. A few instruments might be like balances get more precise, but they're digital. But most instruments are marked out in either tens or ones, possibly 100, 100, like a beaker, because it may show 100, 200, 300, 400, and that's it. So that's marked out in the hundreds, 100. So you would report an answer to the tens, 10 place. But again, you're probably not, I'm not going to, on your test, show you something that is marked out in the thousands, because there's no way we would be able to see the little markings with the way things photocopy. Okay? All right? So there are two problems like that. So
was that our test right there?
Yeah, that's what I'm looking at. That's why we're going over it. Yeah, here, see? Your test on yellow paper tomorrow.
Why yellow?
Well, I thought it was digital.
No, it's not. Okay? Why yellow? Because I knew it would tick you off, Nadia. I said, how can I make Nadia mad on this test?
You're wearing
Yes.
a yellow shirt too. Why don't you wear it tomorrow?
Because I don't color coordinate my outfits to my test.
Looks like a piece of paper
And
too.
second of all, okay, this was on the edge of the closet, so that's the outfit I picked. Okay? All right? Why did you wear green and black?
Why not?
Because black is not really a very Christmassy color. It's supposed to be Christmas week. You're supposed to be dressing up and showing your school spirit, but you're doing it without doing it before Christmas, so there.
You're not even dressed up, so.
Yes, I am. I'm wearing
You didn't
clothes. They
make
got
the
mad at me the one
effort.
time I didn't.
What?
I'm kidding. I'm kidding. It's good to know some of you are paying attention, though. You're still stone-faced. Like, what? Okay. By the way, when you report your answer. Go.
I've learned not to question.
Yeah, if you've had me before, you should learn not to question me. Okay? You should learn not to question me. And you should learn not to believe half the stuff I say about me or my wife. Especially my wife. Don't tell her anything I say.
I'm
Okay?
gonna email her.
jlbrand@kiwani.k12.wi.us.
I already had her email.
How did you have her email?
I don't know. They were friends. On email. Yeah, she's actually my pen pal.
Yeah.
My wife
talk
doesn't
all
know.
the
My
time.
wife doesn't know how to write, so it's not a.
How do you
Yeah,
know?
she
Maybe
does.
she keeps secrets from me. I literally just sent her an email. And I said, your husband just said that he comes to school without clothes on.
No,
That's
no,
what I
no,
just said.
no,
He
no.
said, are you kidding me?
She doesn't remember that time? Anyway, okay. When you make a measurement, ladies and gentlemen, your final measurement shows three things. What three things?
Precision or uncertainty.
That's one. Make sure those go together. Precision and uncertainty is one. What else? A unit and a number. Those are the
Position, uncertainty, unit, and a number.
Run that by me again. I missed the first one. Sorry.
Please, how do you say it?
Precision.
Precision and the uncertainty go together.
That's one.
A unit
A number.
and the number. Okay, those are the three things shown in any measurement. Okay, three things shown in any measurement. All right. All right. You know the base units, ladies and gentlemen, right?
No.
You know the base units, ladies and gentlemen, right?
Yeah.
You know what they measure. You know what instrument to use.
Yeah.
Well, you got to give me 3 out of the 7 on the test.
Oh,
You can pick any. That's less than half of them.
Wait, what? Say that again?
3 out of the 7 base units. You need to tell me what they are, what they measure, and what instrument you would use to make them.
So we could just say,
What? Why not?
Why 3? Why just not 0?
What's she gonna do for my life?
So what you're saying is you want me to do all 7.
No, I want you to do 0.
No, not an option. Okay. All right. Then, ladies and gentlemen, you will be given numbers that you will have to add, subtract, multiply, and divide, and express in the proper number of sig figs. You need to do 3 of the 4 problems, so you can pick which 3 you want to do. Correct units, though. Correct answers, correct sig figs for full credit. Question.
Do you like division?
Do I like division?
Yeah.
I love dividing things, yes, why?
Is that like your favorite thing?
Because
I would like to 4.
yeah, the symbol of existence.
The division is green.
No.
Yeah, sometimes the one thing that I do not like about Google is they don't have a good equation editor,
Shoot.
and they don't have it in Google Sheets. So everything you do in Google Sheets, you got to kind of manufacture on your own.
Do you?
Where with Microsoft, they have a great equation editor that you can put into Word, you can put into a spreadsheet, you can put into their presentations. Google doesn't do that. Go ahead.
Are you gonna give us like the conversion table, or are we gonna have like?
If you need to do a conversion, I will give you the conversion factor.
Wait, the one
So
where
when
you
you need to convert from kilometers to meters, I will give you that 1,000 meters equals 1 kilometer. Like the quiz too. Like we did on the quiz. You need to be able to identify quantitative and qualitative observations. Good. Why? It's either what or what?
Numbers or no numbers?
Numbers or no numbers? Numbers or no numbers?
Wait, what?
Quantitative, qualitative observations, either numbers or no numbers. Okay?
Could you, for our quizzes that we took, you know how like the conversion ones were like, you had to grade them? Can we know if we got them right or wrong?
Yeah, if you go back into your quiz, don't look at, it'll be marked red across the top, but look at the points out of how many points. So when you go back in your quiz,
But-
even any one that I had to grade had a certain number of points attached to it. In your quiz, when you go back and look at it, it'll say how many points you got out of how many.
Can I get a drug test for Tuesday?
Because that's the day that it worked out to be.
That's not nice.
Well, what day do you want? When I schedule them on Friday, everybody, oh, why would you schedule a test on a Friday? Okay, I'll put it on a Monday. Oh my God, you can't give a test on a Monday. That's the day after the weekend. Okay, we'll put it on Tuesday. Why would you schedule a test on a Tuesday? Well, Wednesday is midweek, Mr. Brent. That's not a real good day to have it. And Thursdays, I already have got my mind set for the weekend. You should. It's the way it worked out.
Yeah, exactly.
Here's the other thing. With trimesters, I have to put them on the days when we get to them.
Wait, okay. I'll ask you.
No, go ahead now.
It's about my quiz.
Okay. Then let me get through this, and then yeah, you can ask me in a few minutes.
Are we gonna be starting on the unit right before break?
Yeah, on Wednesday.
Okay.
Okay. You will be asked to look at a number and tell me how many sig figs, like we were just doing. Okay? And you will also be asked to find the uncertain digit. Where is the uncertain digit always?
The last one.
Or no?
99.9% of the time, the last digit is the uncertain one. When is it not though?
It's 0. Actually, I don't know. I'm just guessing.
You are close. That's the worst part.
When it's not a sig fig.
Okay, when would the last digit of the number not be a sig fig?
When there's 0.
When there's zeros and no decimal. Zeros and no decimal. Now the last digit is not the last sig fig. Normally it is, ladies and gentlemen. Normally the last digit is the last sig fig.
So usually the last sig fig is the last uncertain digit.
No, the last sig fig is always the uncertain digit. Always. Always. So if you have a number, 21.30, this is the last sig fig. It is also the uncertain digit, the 0. However, if you have a number that has zeros at the end, and they are not significant because there is no decimal, this is the last sig fig, and it is also the uncertain digit.
That's what I just asked.
And I thought okay, if maybe I misunderstood, I just wanted, it's always the last sig fig, always. No ifs, ands, or buts. It's not always the last digit. Maybe I misunderstood what you were saying.
Yeah, I said so. The sig fig is always the uncertain digit.
Yes, the last sig fig is always, yes, I'm sorry if I confused you. Okay? All right, questions?
Wait, so how many density questions were there?
How many density questions do you have on the test?
Didn't you say we were gonna do calculate density or something?
None.
Are you gonna do some running with density?
No density questions.
Really? Going. What are the rest of the questions?
Well, I'm trying to, but then you asked me a question, so then I answered, and now you like go back to it. Okay. Do you remember on the sig fig worksheet where I gave you some requirements and asked you to write a number?
Yeah.
Number with 5 digits, zeros in the beginning, middle, end, things like that. There are 4 of them, and you need to do 3 out of the 4. You are going to have to create your own number that meets a certain criteria.
How many answers and questions are there on this
Oh,
test?
oh.
Wait, what?
17.
Say that again. Wow, that's really short.
18.
It's
Sorry,
gonna
with
ask us
bonus.
for like certain sig figs and like blah blah. And
Yeah,
we have
it is. It's going to say, give me a number with 3 sig figs that ends in the tens place and has zeros at the end.
Are you gonna give us like the?
Wait.
Are you gonna give us like the little board,
So would that
What do you
be
mean, like a little board?
like where the numbers end? Like
The places?
Yeah.
No.
Why? I need that.
Well, put it on your cheat sheet.
So if they ask us for that, would it be like 5.1 and then 0 0?
No.
Mr. Nash.
Let's make sure we're understanding what I'm saying. Okay?
Mr. Nash.
You called me Mr. Nast?
Yeah.
You called me Mr. Nast?
My bad.
You're terrible.
I was gonna say we should have.
3 sig figs.
We should have been taking notes on the cheat sheet in the beginning.
And ends
I told you from the day I handed it out to you that you could use it on every quiz and test.
You should have been putting it up on the board or something.
Zeros at the end.
I never take it out.
Last digit in the tens place.
Oh.
So give me a number, 3 sig figs, zeros at the end, last digit in the tens place. Start out with a number with 3 sig figs.
3651.
What?
3651.
3651. How many sig figs? What?
Oh, that's
4
4.
6 figs.
Wait, take out the 3. It's a 6.
Replace the 3 with a 0.
We're also confident.
0651.
And then add a decimal between 5 and 1.
Add a decimal between 5 and 1.
No, there's no zeros at the end.
What?
Oh, yeah, the zero's supposed to be at the end.
The ones at the beginning never
65.0.
Yeah, and by the way, this doesn't count as a digit even if you put it in front of the number in the tens place.
I thought that the. Never mind.
Okay? So again, 65.0.
It's a late now.
But there's-
So zeros at the end, I would start with 0.0. Now you got the zeros at the end. Now you need 3 sig figs. Add 2 more digits, 21.
So what if it says
Oh, wait, no,
ends
never
in
mind.
the hundreds?
Okay, what other requirements do you want, Cynthia?
100.
What? But anything else? How many sig figs?
4.
4 sig figs. Any zeros?
In the middle.
Zeros in middle. Okay. Now what I would do for this is I would write a number with 4 sig figs that has a 0 in the middle. That's where I would begin. Give me 4 sig figs. Any number, don't worry about the decimal right now. A number with 4 sig figs with zeros in the middle.
4009.
4009. Now, for that number to end in the hundredths place, where do I put the decimal?
Between the two zeros.
There you go. There's your answer. Okay? Questions?
What if like it says that you need to have like oh never mind.
Now-
I just confused myself. Sorry.
Couple of things. Number one, if it has zeros at the beginning, that means the number has to be less than what?
1.
Less than 1. Okay? So I may not be able to tell you what place the number ends to, but zeros at the beginning and 4 sig figs. So let's start out 0.0. Now, how do I put 4 sig figs in?
3, 2, 1.
1, 2, 3, 4.
Not 3, 2, 1. 3, 2, 1 would only be 3 sig figs.
I thought that 0 counted to the end.
Zeros at the beginning never count.
No, the one.
These are both at the beginning. Any zeros at the beginning never count. Doesn't matter how many are after the decimal or how many are before the decimal. Zeros at the beginning never count. Okay? So you would have to put something on the end like a 0 there. Okay? So that may be what I do too. Zeros at the beginning, 4 sig figs. You can end it wherever you want. Okay, question.
You know a charging block?
Do I have a charging block? I have to go in back and see if there's any more. Hold on a minute. Okay? You will be asked to do 2 metric conversions. They are both 2-step problems. I give you the conversions that you need to do to get from one unit to the other.
Was that always there?
What?
That.
Yeah.
I just noticed that.
Wait, remind me how
Who needed this? Remind you what?
how to when we needed to multiply across through the top and divide through the bottom. What was it?
Okay.
Yeah.
All right. So, if we are going from, let's say, if we're going from kilograms into grams, we need to know that 1,000 grams equals 1 kilogram. So we take 4.250 kilograms times. Now, we either do 1 kilogram over 1,000 grams, or we do 1,000 grams over 1 kilogram. How do we know which one to use? It depends on what unit we're in. We want that unit to cancel. The only way kilograms cancel, go ahead, Cynthia. We use the second one. So 1 kilogram goes on the bottom, 1,000 grams goes on the top. Kilograms and kilograms cancel. When we are done, we will be left in the unit of grams. Now, with our conversions here, part of it will be a number like 10, 100, 1,000. Part will be 1. We don't ever have to do anything with 1. But the way we handle any fraction, we multiply by the number on the top, and then we divide by the number on the bottom. If you're confused as to what to do, you can always do that. Okay? But what I tell people, do you have to divide by 1? So since the 1,000 is on the top of this conversion, we are going to multiply by it. We are going to multiply by it. So therefore, our answer comes out to 4,250 grams. Okay? Now, if we were going from (360 centimeters into meters), 100 centimeters equals 1 meter. 360 centimeters times. Which part goes on top? Which part goes on the bottom? The 100 centimeters or the 1 meter goes where? The 100 centimeters goes on the bottom. The 1 meter goes on top, so the units cancel. So in this problem, because the 100 is on the bottom, we are going to divide by it. 3.60 meters. Okay? So if our number that is not a 1 is on the top, we multiply by it. If it's on the bottom, we divide by it.
So now what if there's
Two of them?
two of them, like two conversions?
We would still do the same thing. If both numbers are on the top, we multiply by both numbers. Both numbers are on the bottom, we divide by both numbers. One on the top and one on the bottom, multiply by the one, divide by the other. Okay? We always just do the math at that point. Okay? Questions? There are also, ladies and gentlemen, 2 bonus problems on the test. They are worth a total of 7 points. If you can answer them, answer them. If you could attempt them and get part of it right, you'll get partial credit. If you don't do anything, you don't lose anything because they're bonus. They're not part of the test anyway. Questions?
Can we get a hint?
What?
Can we get a hint?
Yes. If you know the answer, write it down.
That's not a hint.
No, that's good advice.
Do
That's
you
even
know
better
what the
than a
topic
hint.
is about? Like, can we know what the topic is about?
One of them is a problem associated with the unit, and the other one has absolutely nothing to do with anything in chemistry at all.
What?
One of them has absolutely nothing to do with anything in chemistry at all.
Does that have anything to do with science in general?
It does, yes.
Oh.
This particular one, yes, does. Questions?
Is that it?
Okay. So, what should you be doing now, ladies and gentlemen? Well, some of you have already found it. Some of you have not. In Google Classroom, ladies and gentlemen, in the classwork, there is a Unit 1 test review that if you click on it, looks like this, ladies and gentlemen. You can go through, okay? This is a good reminder of base units. What is the instrument? What is the unit? What is the symbol? What is the measurement? Okay? These are all based on the base units that you should know. Here's those metric conversions going from one to another. Now, I will give you the factor in the test. Here I'm asking you to look it up. What's the relationship between centimeters and meters, kilograms and grams, milliliters and liters? Which digit in this number is the sig fig? Which digit is the uncertain digit? Here's that practice. If you want to take and have to write a number with 4 sig figs and zeros at the beginning and the end. Number with 3 sig figs and a digit in the thousands place. Write a number with 2 sig figs to the 10 or to the thousands place. Here's your math with sig fig. Okay, that's the world's worst division sign, but it was the only one I could find, so leave me alone. Okay, place this instrument read to. Type of measurement it made. Number of sig figs. Notice this one says digital display. Why? Because the rules are different if it's a digital display. All right, write a number, or I'm sorry. Here is the original measurement. Here was the target. This second measurement, is it more or less accurate than the first? More or less accurate than the first? More or less accurate than the first, ladies and gentlemen? Here's an accuracy question, okay? Boiling point of water is 373 Kelvin. A thermometer is reading 371.5. Create a reading that would be more accurate than the one in this problem. Create a number that is more accurate than 371.5 Kelvin. You can, well, you got, remember, accuracy, you got to get closer. So here they want you to create a number that is both more precise and more accurate than the number that the student found, which was 18.8 compared to the target of 19.32. So again, more accuracy and precision work. Here you go. Nadia, you asked before what type or how would it look on the test? What instrument is this? What unit is it reading in? What place does it read to? And then give me the final measurement. Same thing here. Same thing here. And that's it. Now, ladies and gentlemen, here are the answers for it right next to it right here. So even if you do not get it finished in class today, these are the answers for it so that you can see them if we do not get a chance to go over them. So there you go. There's all the table filled in. Here's what the conversions would all look like in your answers, ladies and gentlemen. That should be everything you need to get you ready for the test tomorrow. Questions? All right, I'm going to shut up now and give you time to work on it. If you have questions, please raise your hand, call me over, and I will answer any individual questions you have, including ones on the quiz. So I will be there in a second, Nadia.